Headquarters, can you hear me? There's an alien invasion coming in. The Magellanes gigas, aka the Pacific oyster. It's coming in from the Pacific Ocean and it's heading straight for us here in Tierno. We're gonna sample around Salto Island and find these culprits. Over.
Loud and clear, Jose. I'm looking into it right now.
Oh, I just found it. Biogenic bivalve reefs are coastal habitats serving biodiversity, productivity, and coastal protection, and can be negatively impacted by invasive species.
We are the Guardians of Channel. We have been hired by the IMBRSea board. We are here to assess how the parameters depth, substrate, and exposure, as well as sea surface temperature and chlorophyll A, influence the spatial distribution of the invasive Pacific oyster and the native European oyster around the channel.
It's time to get into the field. As you can see, we've got our 10-metre long transect line with our field agents snorkeling 1 metre either side of our 10-metre transect, making it 20 metres squared. We're doing a count of oyster species, and we're repeating this at the same site within 0.6 metres, 1.2 metres and 1.8 metres depth. Our weapon of choice to study our objective was the generalised linear model using our intergalactic software, RStudio. We log transformed our current data of Pacific and European oysters and fetch data, aka exposure. We ran the interaction between the fetch and substrate type, as well as adding our other parameters, average summer sea surface temperature, depth and chlorophyll A as predictors.
For Pacific oyster, substrate type, summer sea surface temperature, and fetch are significant predictors of abundance. Strong interaction terms were highlighted between fetch and substrate type. The two jointly determine habitat suitability, consistent with the literature. In contrast, the model for European oyster did not produce any statistically significant predictors. The oyster ratio model further supports the importance of habitat, identifying silty substrate, sea surface temperature, and fetch as significant predictors.
A principal component analysis supported overlapping habitat preferences for both species. Higher counts were associated with sheltered and cooler areas, particularly with high spring phytoplankton blooms, mostly found on the northern and eastern coast of Salto. Compact silt substrates found on the same coastlines showed the strongest positive correlation with oyster counts. The exposed and more rocky western coast showed lower counts, suggesting a preferred niche overlap of low-energy environments with salt substrates.
This study aimed to highlight key environmental drivers and found variables such as fetch, SST, and substrate type impacting the distribution of the Pacific oyster and, although with less support, that of the European oyster. The Pacific oyster showed significant responses to these variables. The European oyster did not fully, suggesting missing factors such as mortality or competition may be needed. Nevertheless, the results indicate shared habitat preferences, particularly for productive areas made up of silt that are sheltered.
These findings highlight the potential niche overlap and competitive dominance by Pacific oyster, with large implications for native European oyster population in the future. The study contributes to understanding habitat suitability across the Channel region and helps further our understanding of oyster population in Atlantic waters.